And next on the menu, I'm going to switch paradoxes to something entirely different. And that's called quantum uncertainty. And this is a completely different experiment done with the same cat and the same ball. And in this type of miraculous contraption, the cartoon is meant to illustrate that the ball is able to drop down there and it can't go anywhere except out the funnels. Okay, and let's say that we arrange this in a sort of perfect way where half the time the ball's going to bounce around and go down the left, and the other half of the time, well, down the right. And then we go on again and we ask our cat to conduct this experiment for us many times, and lo and behold, every single time, the cat sees just that. The ball either goes down the right, the ball either goes down the left. Now, this is exactly what we'd expect, but let me tell it to you in a slightly different way. We have a result of a future event, and we look at the past. In the past, there was uncertainty. Okay, so there's uncertainty about the future, but then you have that result about the future. Do you have uncertainty about the past? Right. Although we can't be certain which of the funnels the classical ball will fall down, after we observe where it lands, we can retroactively reason as to what happened. We can use information about the present to understand what took place in the past. But I'll show you that in quantum physics, you can't always know the past. That's one of the things that makes it strange. So just to remind you that this is not quantum tunneling. The ball cannot tunnel. So we repeat this and we blindfold our cat so as not to disturb the outcomes of the experiment. We yet again release the ball, but this time it's a quantum particle. And it can't tunnel through. It has to go through the funnels. Okay? And we ask our cat, we say, do this experiment for us. And the cat finds that most of the time it lands in the middle. So that's strange. That's pretty strange, but we can, okay, that's strange. So we'll explain that, but then we'll say something even odder. So when you look at a quantum particle like a ball, you see it. It has physical shape. But when you don't look, it behaves like a wave. And in this particular case, it behaves like a wave and it travels through both the slits. Then the wave's add and it lands in the middle. But that's not why I want to show you this. What can we say about the past if we have that information? What can we say about the past? We can know where the ball ended up, but not where it started or what its trajectory was. Not being able to know the past based on our current state of knowledge is a feature of quantum uncertainty. So although we're used to dealing with uncertainty in future events, we're not used to dealing with uncertainty about past events given all the information you need to construct a history. And that is why quantum physics is very strange.